Good morning, Tehmina Khan is here in TKMaths S1. In today's video, we will see a question on kinematic of motion in a straight line. This is a topic of the A-level mathematics syllabus M1. The question I've taken is from November 21, variant 4.3, question 5. The topic kinematic of motion in a straight line has various aspects. You can see here in the syllabus list. In this question, I am covering the aspect of using differentiation and integration with respect to time to solve the question. So let's see the question, and for the remaining questions you can visit my blog address and my website address, which is given here. So let's begin with the question. So before we start, you need to recall this concept. When displacement equation is given to you and you have to find out the velocity equation, you differentiate it, right? And when velocity equation is given to you and you want to find out acceleration equation, you differentiate it. Whereas if you go in the reverse order from acceleration to velocity, then you need to integrate the equation. Similarly, if you have a velocity equation and you have to find out displacement equation, you integrate it, right? So let's see the question here now. This is question number 5. A particle P moving in a straight line is starting from rest at O on the line. Now O is the reference point. These informations are very important, right? So see what values and what information I get from these three lines. At time t seconds after leaving O, the acceleration is given here. So this equation k bracket 16 minus t square is the acceleration equation. So this is given to you here, right? So question is saying k is a positive constant and the displacement from O is s meter. It means displacement is from O. So when the object initially was at O, so information we have is when t0, s0. And because it was at rest, it means when t0, v was 0. So another information we have. And lastly, it is said that when velocity was 8 meter per second, the time was 4 seconds. So this last information is given to you specifically, whereas other two you understand from the question. Now let's see. Acceleration equation is given to you and you have to find this displacement equation. It means you have to integrate it twice. One time when you will integrate acceleration equation, you will get a velocity equation. And I hope you remember the basic integration, right? So when I integrate the acceleration equation, you can see here, the constant I am taking out here, and 16 will become 16t minus t cube over 3. So this is the basic integration you have learned in P1 last year or in Add Maths in O level. Plus c we write as an arbitrary constant. I'm not going into the detail of how to integrate because this is a prerequisite for this course. You can refer my videos on integration if you don't know how to integrate it. Okay, so to find out the value of unknown, I am substituting this information given to me here in place of v and t. So when v is 0, t is 0, so this whole thing will become 0 minus 0, so c will be 0. So equation of velocity will be this without c because c is 0. Now we will integrate it one more time because we have to find out the displacement equation, right? So now this is your velocity equation. When you substitute the values of v4 and t8, which is here, why we are doing that? To find out the value of k, and then we will integrate. If you want to integrate first, you can do that also, but it will become a little complicated, but not impossible. So after integrating it, after substituting the value of v and value of t, you get the value of k, which is 3 upon 16. So now this 3 upon 16 you can replace here, and then after that you can integrate it. So if you see here, this is the displacement. I have substituted the value of k, 3 upon 16 here. And the rest of the term I'm writing as it is right now. After that, I integrated it. So 16t will become 16t square upon 2. T cube upon 3 will become t power 4 divided by 4 into 3. And I'm using another letter here. C I have used earlier. So now I'm using d. Now to find out the value of t, I need to plug in the value of s and t. So from the question, this information was given to you. So I will plug in t0, s0 and I will get d0, right? So simple substitution and you got d0. After that you got your displacement equation, which is equivalent to what you have to prove. Now see one thing, I got this equation, but I have to prove that it is equals to this one. So you will manipulate with the equation, you will take out the common factor according to the requirement, right? So I have taken here, after opening the bracket, 1 upon 65 out and t square common factor. And I got 96 minus t square. So this is how I proved the displacement equation. Now the next part of the question is saying, find the speed of p at the instant that it returns to O. Now hint is given here. Returns to O implies that your displacement is 0, right? You are back to the point from where you have started moving. So if I have to find out the speed, I will substitute t in the displacement equation, in the velocity equation. But what value of t I will plug in? The value of t at which the object returned to O. So in this equation, I will substitute s0 and then I will try to get the value of t, right? And that value of t I will plug in the velocity equation. So here is the velocity equation, right? To get the value of t, we will use s0 in the displacement equation. So this is the equation. I'm substituting s0 and then I will simply solve this equation. It's simple quadratic power 4 equation which we have factorized square, and that's why it will be easy now. So time cannot be negative. It means I will take t is equals to root 96. Now some people take here decimal values, fine, but I would suggest that use the exact value. It will give you accurate answer for the next part of the question, right? So now I got the time at which the object returned to O, right? And this value of t I will plug in the velocity equation because I have to find the speed. Now there is also something very interesting. When you substituted the velocity equation, you got minus 29.39, right? And in 3 significant figure, it will be minus 29.4. But what was question saying if you have read it carefully? It was saying find the speed, and what we have found? The velocity. So what's the difference? The difference is for speed, you will only mention the magnitude. You will not mention sign plus minus, right? Plus minus have different meaning. So you will just say speed is 29.4 meter per second. So be careful if you are targeting to get distinction, you can't afford to lose single mark, right? Now find the maximum displacement of the particle. So what is the hint here? The hint here is that at maximum displacement, what will be 0? Velocity will be 0. So now you will put velocity 0 in the equation to get time. And that time you will plug in the displacement equation. So, okay, so you have to focus on the hint given to you here. So maximum displacement means velocity 0. So let's do this. So I will substitute V0 in the equation of velocity and I will try to get time from there. So this is my velocity equation which we have found in part 1 and I'm putting V0 here. And simple calculation, I hope you know this. I have taken LCM here, cross multiplied, then I factorized it. I took t common out. So I got 2t0 and t square is 48. So t is root 48. Again, I'm taking only positive value because time we do not take in minus here. So now I have a time and this time I will plug in the displacement equation because I have to find out what was the maximum displacement covered at that time. And this was the time when velocity was 0. So now you simply substitute the value in the displacement equation. You can see I have plugged in here and I solved it with the help of calculator. I got the displacement 36 meter. So thank you very much for watching this video. I hope you understood the concept. So Please press like and subscribe to encourage me and share it with your friends. Take care.